The artificial intelligence landscape is rarely quiet, but every so often, a release occurs that fundamentally reshapes the foundation upon which developers and researchers build. Today, that silence has been shattered by the official unveiling and initial rollout of Gemma 4. This is the latest generation of open-weights large language models from the architects at Google DeepMind, representing a calculated and powerful shift in the global AI arms race. While proprietary models often dominate the headlines, the sudden surge in documentation and repository updates on GitHub and Hugging Face told a different, more democratic story. This was a global event, with the weights being made available simultaneously through Google AI Studio and Vertex AI, ensuring that from the moment of launch, the world had access to this new level of intelligence. The objective was simple: to regain dominance in the open weights category, a space that has become increasingly crowded. To understand why Gemma 4 is such a monumental achievement, one must look back at the lineage that birthed it. The story began with Gemma 1, which established the basic foundation of Google's open weights philosophy. It was a solid entry, but it was Gemma 2 that truly changed the game by introducing the innovative distillation technique. By training smaller models on the outputs of their massive siblings, Google DeepMind discovered how to make a compact model punch far above its weight class, delivering performance that rivaled industry giants. Then came the Gemma 3 bridge. This was the crucial evolutionary step that integrated native multimodal capabilities, allowing the ecosystem to move beyond simple text and begin processing vision and code within a unified framework. This transition set the stage for the massive architectural leap found in version 4, moving the ecosystem toward a unified transformer architecture that feels more intuitive and powerful. Google's open weights strategy is a fascinating study in corporate adaptation. A company historically known for its guarded proprietary systems is now investing billions into fostering a public developer ecosystem. This shift is a direct response to the intense market pressure of late 2024 and 2025. Meta's Llama series, particularly the 3.1 and the highly anticipated Llama 4, had begun to capture the imagination and loyalty of the open-source community, offering freedom that closed models could not match. Alongside the rising efficiency of small language models from rivals like Mistral, Google faced a clear choice: adapt or lose its influence over the next generation of developers. Gemma 4 is their definitive answer, designed to provide high-level intelligence that can run on private servers, ensuring that startups and researchers can innovate without the constant burden of high API costs or the privacy concerns inherent in cloud-based systems. This vision of accessibility is backed by significant hardware synergy. Gemma 4 is specifically optimized to harness the sheer processing power of NVIDIA's H200 GPUs and Google's own internal TPU-v5P clusters. However, the brilliance of its design lies in its remarkable scalability. While it can handle massive enterprise-level workloads on large clusters, it remains surprisingly accessible for those working with consumer-grade hardware. Even an enthusiast with an RTX 4090 can find a home for these models in a local environment, proving that the barrier to high-level reasoning is lower than it has ever been in the history of the field. This flexibility is essential in a landscape where small language models are becoming increasingly proficient, forcing the industry's giants to prove their utility in every possible configuration, from the data center to the desktop, ensuring that performance is never sacrificed for portability. Before we continue, subscribe to the channel and tell us in the comments where you are watching from. This global community of creators and thinkers is what drives the evolution of these models forward, and your presence is a vital part of the story. The rollout of Gemma 4 marks a point of no return for the industry. By focusing on the developer experience and providing a clear path from mobile-friendly variants to heavyweight giants, Google DeepMind is building more than just a model. They are building a new standard for open intelligence. As the tech world begins to analyze the initial benchmarks and deployment data, it is obvious that the focus has shifted from mere parameter counts to true functional utility. This is a new frontier for AI, where the most advanced tools are finally within the reach of everyone who has the curiosity to use them. The journey through the technical heart of this machine is just beginning, as we prepare to peel back the layers of its complex architecture. Deep diving into the technical heart of Gemma, 4 reveals an architecture meticulously designed for both extreme versatility and raw computational power. Google DeepMind has carefully structured this release into several distinct parameter sizes to address the diverse needs of the modern digital landscape. At the most accessible end of the spectrum sits the ultra-efficient 2B variant, a model specifically engineered for mobile devices and edge computing where power consumption and latency are critical factors. Moving up the scale, the 9B variant serves as the balanced middle ground, offering a perfect sweet spot between deep reasoning capability and manageable hardware requirements for diverse small businesses. For the most demanding tasks, the heavyweight 27B and 70B versions represent the true pinnacle of the series. Like pushing boundaries for open weights models in private environments, what sets this generation apart is the native multimodal integration that defines its core logic. Unlike previous iterations that often relied on separate adapters or external modules to process different data types, Gemma 4 utilizes a unified transformer architecture. This allows the model to process text, complex code, and high-resolution visual data simultaneously within a single cohesive framework. This approach mimics the way humans naturally perceive and synthesize information across different sensory inputs, allowing for a more holistic understanding of the prompts it receives. The expanded context window is a significant leap from the predecessor. While previous industry standards had often hovered around 128,000 tokens, Gemma 4 shatters those constraints by supporting a massive 1 million token window. This transforms the model into a powerful tool for large-scale codebase analysis, enabling developers to feed entire repositories into the system to identify bugs or refactor logic without losing the broader context of the project architecture. Behind the scenes, the training methodology has also seen a sophisticated overhaul. To ensure safety, Google DeepMind employed a combination of reciprocal rank fusion and reinforcement learning from human feedback. These techniques allow for a much more nuanced refinement of the model's responses, sharpening its ability to follow complex multi-step instructions while maintaining robust and transparent safety filters. This balance between raw creative potential and ethical responsibility is a cornerstone of the Gemma 4 philosophy, ensuring that as the model grows more powerful, it also becomes more reliable for enterprise and high-stakes research applications alike. Performance metrics suggest that Gemma 4 is not merely competing with its rivals, but is often leading the pack. In the massive multitask language understanding benchmarks, the model demonstrates striking proficiency, frequently matching or exceeding the scores of Gemini 1.5 Pro in specific technical domains. This is particularly impressive when compared against the Llama 3.1 series from Meta, showcasing that Google has successfully closed the gap in the open weights arena through superior architecture rather than just brute force. Coding proficiency has also been a major focus of this release. On benchmarks like Human Evil and MBPP, Gemma 4 shows specialized tuning for languages such as Python, Rust, and C++. The model does not just suggest snippets, it demonstrates a profound architectural understanding of complex software patterns. Hardware collaboration with NVIDIA has paid significant dividends. For local deployment, the tokens per second metrics on consumer hardware like the RTX 4090 are remarkably high, proving that a user does not need a massive server farm to run high-fidelity AI. This efficiency extends to the model's reasoning capabilities through improved chain-of-thought processes. Furthermore, the model's global nature is reflected in its expanded tokenizer, now supporting over 100 languages. Gemma 4 provides significantly lower latency for non-English queries, making it a truly international tool for the global developer ecosystem. This multilingual support ensures that developers in diverse linguistic regions can leverage the same high-level reasoning without being hampered by translation artifacts or cultural biases that often plague smaller, English-centric models. These breakthroughs position Gemma 4 as a formidable player, ready to challenge established rivals like Mistral and Meta in this fast-paced race. The arrival of Gemma 4 does more than just move the needle on technical benchmarks. It fundamentally shifts the power dynamics of the entire artificial intelligence industry. By offering such high-level intelligence in an open weights format, Google DeepMind has initiated a democratization of power that was previously unimaginable. Small startups, which were once tethered to expensive and often restrictive proprietary APIs, now find themselves running Gemini-class reasoning on their own private servers. This shift significantly lowers the barrier to entry, allowing for a surge of innovation that doesn't require a massive venture capital infusion just to cover cloud computing costs. This transformation effectively breaks the long-standing monopoly that closed-source giants held over advanced reasoning, forcing a rethink of how AI value is captured and distributed. This paradigm shift is particularly evident in the edge AI revolution. With Gemma 4, high-performance reasoning is no longer confined to the data center. Modern laptops and smartphones are increasingly capable of hosting these models locally, a move that provides an unprecedented layer of data privacy for enterprise users. For a legal firm or a medical research facility, the ability to process sensitive data without ever sending it to an external server is not just a convenience, it is a requirement. The local execution of these models ensures that intellectual property remains secure within the organization's own hardware, bridging the gap between cutting-edge intelligence and strict regulatory compliance. This local hardware capability ensures that the developer ecosystem can experiment without fear of data leaks. As the developer ecosystem absorbs these new capabilities, we are seeing an immediate surge in specialized, fine-tuned versions of Gemma 4. In repositories across GitHub and Hugging Face, variants are appearing that are tailored specifically for niche industries. Medical professionals are seeing models optimized for diagnostic reasoning and research synthesis, while legal experts are utilizing versions trained to parse complex case law with surgical precision. Even the creative and technical writing community has found a new muse, as fine-tuned variants of Gemma 4 demonstrate a nuanced understanding of narrative structure and stylistic flair that rivals the most famous closed-source models. This explosion of tailored intelligence suggests that the era of one-size-fits-all AI is ending, replaced by a modular world where every field has its own specialized version of the protagonist model. This surge in capability naturally intensifies the open versus closed debate. Gemma 4 complicates the narrative that proprietary systems like GPT-4o or Claude 3.5 are inherently superior. When a model that can be studied, audited, and modified begins to match the performance of its closed-source counterparts, the argument for transparency becomes much harder to ignore. However, this openness brings its own set of challenges. The dual-use nature of high-performance models means that the same tools used for medical breakthroughs can, in the wrong hands, be repurposed for automated phishing or creating misinformation. Addressing these significant security concerns is a priority for Google DeepMind, leading to the development of specific safety variants to curb potential misuse while maintaining the model's core utility. Looking toward the immediate future, expectations are high for the release of Gemma 4 Instruct and Gemma 4 Shield. These specialized variants will further refine the model's ability to follow complex directives and provide an extra layer of protection against adversarial attacks. Furthermore, Google plans to use Gemma 4 as a distillation target for its proprietary Gemini models, creating a constant feedback loop where each generation makes the next faster and more efficient. The next battleground looms as Meta prepares its response with the rumored specifications for Llama 4. This arms race between tech giants, including pressure from rivals like Mistral and NVIDIA, serves as a massive benefit to the end user, as each iteration pushes the boundaries of what is possible in the open weights category. As we look even further ahead to the eventual transition toward Gemma 5, questions of sustainability and architectural evolution come to the forefront. While current trends favor larger context windows and higher parameter counts, there is a growing interest in liquid neural networks that could offer even greater efficiency. Whether Google chooses to scale or pivots toward these more fluid architectures, Gemma 4 stands as a definitive milestone. It marks a point of no return for high-performance OpenAI, making it the most impactful and significant release of the current quarter. By providing a bridge between the laboratory and the local machine, it has ensured that the future of intelligence is not just powerful, but accessible to everyone. The story of Gemma 4 concludes here, but its influence on the future of technology is only just beginning.